charge. So therefore, we need to do some working as far as that is concerned. Note 1 is concerned, which you are saying is a fair value adjustment, or basically the fair value exercise. Let's just refer to it as the fair value adjustment, and this is by paper limited. By paper limited. So we need to make two adjustments as far as this is concerned. The first one is called the revaluation adjustment. And basically, this is the adjustment in relation to the revaluation gain or loss. But remember, you said in most of the questions for group account, you'll come across a revaluation gain. So that's why we are told in the first paragraph, in the first sentence of note 1, we are told at the date of acquisition, the fair value of paper limited net asset approximated the carrying amount, with an exception of an item of office equipment whose carrying amount was 560 million below. So this one was below or was less than fair value with 560 million. In other terms, here we can say the fair value, we start with the fair value, then we change this inequality sign. Remember, this was less than. So we change this now to greater than. If we start with this, so this one will be greater than carrying amount with an amount of what? 560. So if the fair value of an asset is more than its carrying amount, automatically that is a revaluation gain. So the fair value of this item of office equipment was more than carrying amount. Remember, carrying amount, this one can also be known as the net book value with an amount of 560 million. So because this revaluation, okay, this 561, we are saying this is a revaluation gain. This is a revaluation gain by paper. Did the paper limited accounted for this revaluation gain? No. So therefore, in preparing the consolidated financial statement, this one will be added to the group PPE. And number 2, we say that this one is a pre-acquisition revaluation reserve. Being a pre-acquisition revaluation reserve, we use that in the computation of goodwill, because we say in computing the goodwill on acquisition of this, we need to have we need to compute its fair value. We need to compute the fair value of its net asset on the date of acquisition. How do we compute that? We take the ordinary share capital of the subsidiary plus pre-acquisition reserves. This will be one of the pre-acquisition reserve. Next, we need to compute something called the depreciation other charge. Depreciation other charge. And equally this depreciation other charge will be by paper, is by paper limited. So you need to recall the formula. There is a formula which I gave you here. That is basically what you need to remember. We said we take the revaluation gain, divided that with the remaining useful life of the asset, and then we multiply this with what? With the proportion of time. The proportion of time is basically the time we have, or basically the number of years, the number of months we have, from the date of acquisition, the date of DOA, to the date of consolidation. Remember, the date of acquisition is the date the subsidiary was acquired. The subsidiary was acquired on which date? There, 1st of April 2024. The date of consolidation, this one, DOC, this is the date we are required to prepare the group accounts. And if you go to the requirement, you'll be able to see when are we required to prepare the group accounts as per the requirement. The year which ended 31st of March 2025. So that is the date of consolidation. And actually this year, because the year of the group is ending at 31st of March, it starts on 1st of April. So this year started on 1st of April, 2024. So therefore you can see our subsidiary here was acquired exactly at the start. Was acquired exactly at the start of what? Of the year. So therefore, the proportion of time we have here will be 1 year. Will be one what year? We're interested with the depreciation other charge for 1 year. We will take the revaluation gain, which we have here, 560 million. We are applying this formula. We divide that with the remaining useful price. And I hope you can see that within note 1. Can you see the remaining useful price? How many years? In
value. When present value to future value, when we are doing present value to future value, we call it compounding. This one you must have done in mathematics, compounding. Compounding, it is determination of a future value from a present value. Determination of a future value from a present value. For example, in our example here, You have been given 1 million. You want to know, if I get this 1 million today, I'm going to invest. Remember, you're not just getting the 1 million and keeping it maybe under the bed. No, you'll get the 1 million and invest somewhere. If you invest, it will earn a return. So after 10 years, you will not just have 1 million, but you'll have 1 million plus a return. So we want to know this 1 million plus the return that you're going to earn, how much will it be after 10 years? That is determining the future value from a present value. And that is what we call in compounding. That is compounding. The other one, we are moving from future value to present. Like in this case, you're being given 2 million shillings after 10 years. But we want to know what is the worth. What is the worth of 2 million shillings 10 years to come? What is the present value of this amount? So you go backwards. Working from future value to present value, we call it discounting. Discounting. This is discounting. Discounting its determination of a present value from a future value. Determination of a present value from a future value. And I've said, when you are given an amount in present value terms and another amount in future value terms, and you're supposed to compare the two, you cannot compare when they are not in the same form. You're supposed either to convert them to present value or to future value and make a decision or make a conclusion. That is all about time value of money. So let's see what we have in the handout. There is a handout I've just shared. There is a handout I've just shared in the WhatsApp group. Kindly check. Kindly check. Have you seen that handout? I shared just a few minutes before the class. I want us to look at it. In case you have a question, you can ask before we proceed. In case you have a question, kindly ask. Okay, fine. Let's. I want to believe you've seen the handout. It's important to respond. Kindly respond if you've seen the handout. Okay, fine. Let's continue. Thank you, Alice and Akin, Alan as well. So up there, you can see the introduction, concepts of time value of money. Introduction. A shilling today is worth more than a shilling tomorrow. All what I've explained is what you can find there. Future value techniques. Future value techniques, you can see there we have future value. That is what I've explained. An amount that will be paid or received in future, we call it a future value. Then we have present value techniques. Present value, I've said, is an amount today. As an amount today, present value. Compounding techniques, but I'm not saying you are going to make sure you go through this, the theory part, at your own free time. But this is what I've just summarized. There is no need of repeating. I just want us to walk through. Compounding techniques, we've said, okay, this is what we did in mathematics. Simple interest and compound interest. So again, that is not important, so much important. I just want us to look at the, but let's, yeah, we are under compounding techniques. Here we've talked about two concepts, the concept of compounding, the concept of discounting. So I want us to start with compounding. That is compounding techniques. That's the reason why there they are saying compounding techniques. Compounding techniques. So we start with the compounding techniques, number one. Determination of a future value from a present value. Compounding techniques. Compounding techniques. Now, we start with future value of a lump sum. Okay, in here, we will not focus too much on the illustrations that we have there in the handout. I want you to make short notes. I want you to make short notes as we continue. I have some handwritten notes here that I want to share with you. So just write concepts of compounding, or compounding techniques, and we start with the first one: future value of a lump sum. 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 Alan? Okay, I will share. But the handout is more summarized. So we start with future value of a lump sum. Now, when you talk about, the most important thing here to understand is what is a lump sum? What is a lump sum? A lump sum, this is an amount that is received or paid once. An amount that is received or paid once is what we call a lump sum. For example, let's say if you pay or receive 2 million shillings today, that is a lump sum. Or if you invest, let me show you. Let's first understand. We have two things here. We have a lump sum. We have a lump sum. And we have an annuity. And an annuity. So here, let's say we have periods. We have period 1, 2, 3, 4. So we have amounts. Let's start with lump sums. Lump sum amounts. Lump sum. Let's say in year 1, the amount is 300,000. In year 2, it's 550,000, 600,000, and 700,000. These are what we call, all these are lump sums. Okay, let's have annuities. Annuity amounts. These are like installments. They are equal 400,000, 400,000, 400,000, 400,000. So annuities, they are equal amounts received or paid regularly. Equal amounts received or paid regularly. And when we say regularly, we are saying it's either monthly, weekly, semi-annually, yearly, quarterly. That means like every month you are paying or receiving 400,000. That is an annuity. Or each year you are paying or receiving 400,000. That is an annuity. Equal amounts received or paid regularly. Lump sum amounts. Lump sum amounts, you're saying this is an amount which is received or paid once. They do not repeat themselves. For example, in year 1, you'll receive 300,000. In year 2, you're getting 550 or paying or 550. Year 3, 600. Year 4, 700. Maybe let's say year 5, 300,000. You cannot say that since 300,000 is appearing twice, that it is an annuity. No, it is not an annuity because it has not been received regularly. You've received 300,000 after some other cash flows have been received here. Are we together? So all these are lump sums. All these are lump sums. However, if, for example, if you get 300,000 here and 300,000 here, we have two 300,000s that follow each other, this one and this one. This one will be referred to as an annuity. This is an annuity. Year 1 and year 2, or period 1 and period 2, we have an annuity of 300,000 because they follow each other. Yeah. But if the 300,000 occurs after, let's say, for example, here we have 700,000 and here we have 300,000. So in year 1 and year 3, we have 300,000. These are not annuities, they are lump sums because in between them, there is a figure that is different from them. I want to believe that is very clear. That is clear, a lump sum and an annuity. This is a concept that we are going to use a lot in financial management. And that is why I want you to be able to differentiate lump sums and annuities. Again, so this was 6. Let's say this was what? This was 500. Let's say now, yeah, 300,000 there. 300, yeah, let's say 300,000 here. So in year 4 and year 5, the 300,000 becomes an annuity because they follow each other. We have two 300,000s that follow one another. So they are annuities. So I want to believe that is clear. That's okay? Okay, fine, let's proceed. So we now looking at future value of a lump sum, future value of this kind of cash flows, future value of this kind of cash flows. So when you want to determine the future value of a lump sum, future value of a lump sum, future FV, its future value of a lump sum is equals to present value, or let's say principal, what you are used to, principal times 1 plus r power n. Principal times 1 plus r power n. And this is what you call present value. Present value. This principal figure here is what we call present value. Let's see. Let's see what we have in the handout there. Check what we have there. Where are we? Where are we? Future value of future value of a lump sum should be there. If you look at the handout, you'll see using tables to find future value. Equation for finding future values of a single amount is derived as follows. How it is derived is not so much important to us. The most important thing is this. Yeah, this is how we get the future value of a lump sum. Future value of a lump sum is equals to principal into brackets present value times 1 plus r power n. This factor here, this factor 1 plus r power n is called what? Future value is called future value interest factor. This one is called future value interest factor. Future value interest factor. That factor is called future value interest factor. This one is very important. 1 plus r into bracket power n. So here we can say where FV is future value, R is the discounting, or not discounting rate, but rate of return. It's important for you to write this formula. Just write this, just write that. Rate of return is like the interest rate. Rate of return is like the interest rate. Yeah. Do we have an example there? So the example, yeah, there should be an example somewhere. Yeah, there is an example there. Look at that example. They're saying Assume that you've just invested Kenya shillings 100,000. The investment is expected to earn interest at a rate of 20% compounded annually. Determine the future value of the investment after 3 years. So, okay. Let's look at that. We are doing that illustration, that example. We're saying, assume that you have invested shillings 100,000. That is the present value. That is the principal. The principal amount, which is present value amount, is Kenya shillings 100,000. 100,000. Then the investment is expected to earn interest at the rate of R is 20% per annum. This per annum is very important. Okay, it is not given. They have not said per annum, but we say when you get a rate of return where the period, whether the per annum, per month, semi-annually is not stated, the standard measure is per annum. So unless it is specified like semi-annually or what, you should take it as per annum rate. So per annum is 20%, compounded annually. Determine the future value of the investment after 3 years. N, we should have said N here. N is equals to number of periods. Number of periods. Kindly have that. Number of periods. Number of periods. Make sure you write that. So here, our period is 3 years. We are investing for 3 years. So future value we are saying is equals to present value 1 plus R power N. So future value is equals to 100,000 times 1 plus 0.2 power 3. Power 3. So get the value of the investment after 3 years. Value of the investment after 3 years is how much are you getting? There are people, no, but you must be knowing how to put this power 3 in calculators. Anyone who doesn't know, you will be assisted. Now, for example, we have two answers here. We have 172,800 and we have 106,120. Alice, I'm doubting your answer. At a rate of 20%, even in the first year, we are going to earn 20,000. Because first year one, we will say 20% times this. Times 100,000, that is 20. That means it's more than 106,000. So 178, probably 172,800. 172,800. At least repeat your calculation. Okay, yeah, 172,800. That is what you're supposed to do. Another method of getting this. Another method of getting this is OR. So here you say OR, a very long method. You'll say period here, period 1, 2, and 3. Amount, let's say 100,000. No, will that give us? No. No, that is the only way. Okay, the other method is where we say, but this one is very long. Where you say here it's 1 plus 0.2. The figure that you'll get here, you bring it here. Then you continue you continue, but that will not apply in this case because we are only investing one. So you can continue, you grow by that rate, So just stick to this. Just stick to this. Any question before we continue? We want to proceed. Okay, number 2, future value of an annuity. Future value of an annuity. Future value of an annuity. Future value of an annuity, and you have seen how we get the future. I've explained what's an annuity. Future value of annuity. Future value of annuity. Now, a future value of an annuity, just like we've said, you get the annuity. It's an annuity when the amount occurs repetitively, but regularly. So future value of an annuity is computed as follows. Without wasting a lot of time, future value of annuity is equals to the annuity. You get the annuity amount times annuity amount times. So we have the future value annuity factor. The future value annuity factor, you say 1 plus R power n minus 1 over R. That's how we get the future value of an annuity. 1 plus R, and write these formulas because the way they are in the handout. Okay, they are very much simplified in the handout. Just write what I'm writing on the board. Yeah, it's there, but write. Future value of an annuity is equals to annuity times 1 plus R into brackets power n minus 1 over R. This factor here, the factor 1 plus R power n minus 1 over R is called future value interest factor of an annuity. Future value interest factor of an annuity. What have they said there? Future value interest factor of an annuity. Future value interest factor of an annuity. This one. Now, we have tables. We have tables where these factors can be read from. Like you remember what table do we have? We have math table. Do you people know what's a math table? Or maybe what we call what? Normal curve, normal distribution curve. We have tables. We have tables where you can read these factors. When we go to discounting, I'm going to share the tables so that we can see. But for future values, the tables for compounding, it's not widely used in financial management. So just get these formulas right. Yeah. So any question here? There is nothing to explain. We know R is the rate of return or the interest rate. N, it's the number of periods. So there is nothing to explain. Let's go to what? Let's have an illustration. Do we have an illustration there? From the above example, there is a statement that says no. We have an example. What is the value of shillings 100,000 investment annually at the beginning of each of the next 5 years at an interest of 12%? Are you there? Have you seen that example? And finding future value of an annuity. Oh, that's due. Sorry. What is the value of 100,000 investment annually at the beginning? That's an annuity due. We are coming to that. I want us to have an illustration on the illustration on future value of an annuity. Okay, let's say from the above example, there is a part that is missing here. There is a part that is missing, but all in all, let's just write an example there. Just write something. Just write an example, an illustration. Say an investor intends to invest. An investor intends to invest shilling 60,000 at the end of each year for 4 years. An investor intends to invest shilling 60,000 at the end of each year for 4 years. At the end of each year for 4 years. Full stop and say, the investment will earn interest. The investment will earn interest at a rate of 20%. The investment will earn interest at a rate of 20%, compounded annually. The investment will earn interest at a rate of 20%, compounded annually. Compounded annually. Full stop. Determine the future value. Determine the future value of the investment. Determine the future value of the investment after 4 years. Determine the future value of the investment after 4 years. Determine the future value of the investment after 4 years. After 4 years. Now, future value of the investment. Now we start. This is how you should be approaching these questions. You first analyze the question. For example, here we are saying amount to invest is 60,000 at the end of each year. So annuity. We say annuity. Shillings 60,000. Annuity shilling 60,000 at the end of each year for 4 years. Period is 4 years. 4 years. Then the investment will earn interest at a rate of 20%. So 20% per annum. So we want the value of the investment after 4 years. So future value of annuity is equals to the annuity times 1 plus r power n minus 1 over r. So here you say 60,000 times 1 plus 0.2 power 4 power 4 minus 1 over 0.2. So get the value of the investment after 4 years. Then I show you another way of doing it. Get the answer, get the answer. Get the answer. 322,080, 322,080. Another person, 322,080. Another person, Alice. Okay, that's fine. Now, there is another way of doing this question. So this is now, you say period, period, 1, 2, 3, 4. Annuity or amount. Remember, this person is investing 60,000 at the end. Yeah, at the end of each period. 60, 60, 60, 60. At the end of each period, this person is investing 60. So here you say 1 plus R power n. If we want to treat each amount as a lump sum, then here we will have future value. Future value. So here we will have 1 plus R, 1 plus R. This is 0.2. 0.2. 1 plus 0.2. 1 plus 0.2. 1 plus 0.2. 0.2. 1 plus 0.2. So before that, we know we've not put n. That is what I want to illustrate here. That is what I want to illustrate here. So we are 0. We always start at 0. 0 means now 1, 2, 3, 4. We're talking about 4 years, which is 1, 2, 3, 4. So here we have at the end. We are investing at the end. So at the end of the first year, 0, 60, 60, 60, 60. I want us to put n. So this 60 that you've invested at the end of year 1, how many times will it earn interest? The 60 that you invested at the end of year 1, how many times will it have earned interest at the end of year 4? It is here. 1, 2, 3. We have invested 60 here, so it will earn a return here, a return here, and a return here. So you say power 3. That is power 3. Then the other 60 at the end of year 2 here, it will earn interest here and here. So you say power 2. The 60 that you invest at the end of year 3, it will earn interest once. So you say power 1. And the last one, the 60 that you are investing at the end of year 4, it will have earned no return. So you say power 0. So multiply and get the total. If you multiply and get the total, we should be getting the same answer as this. We should be getting the same answer as this. So the reason why I just want you to get the concept, the concept here of power what, power what, power what. So 103,680 must be the first one. 103,680. 103,680. 86,400. Uh-huh. 72,000 and 60,000. So get the total. Get the total. 322,088. Yeah. So almost the same as what we have here, just because of rounding off, that's where there are differences. So is that okay? Let's proceed. Let's do the next one, then we go for a break. The other one is future value of an annuity due. Future value of an annuity due. Let's wrap this. Future value of an annuity due. Now, what we have talked about here, it is an annuity that occurs at the end of the period. So here we had 60. If an annuity occurs at the end of the period, like in this case, that is what we've done in part B. But now we have what we call, okay, fine, Alice, 080, okay, fine. So future value of an annuity, this is when the amount is invested or paid at the beginning of the year, at the beginning of the year. For example, if our 60 here, 0, 1, 2, 3, 4. If the investment is done at the beginning of the year, for example, here 60, 60, 60, 60, 60, we call it 1, 2, 3, 4. This is not there. We call it an annuity due. So an annuity due is an amount that is invested or paid at the beginning of the period. And this will change because now, like here we had said this is power 3 because we counted here 1, 2, and 3. But if it's an annuity due, we will now have 1, 2, 3, 4 because we are going up to the end of year 4. Because we are going up to the end of year 4. So the amount that we invested at the beginning of year 1 here will earn interest 4 times. 1, 2, 3, 4. The amount that we invested at the end of year 1 will earn interest 1, 2, 3. This will earn 1, 2, and this will earn 1. So the entire thing will change there. But now, how about when we are using the formula? When we are using the formula, this is how we get the future value of an annuity due. So here we say future value of annuity due is equals to annuity times 1 plus r power n minus 1 over r. Then we add another factor here, 1 plus r. 1 plus r. 1 plus r. 1 plus r power n minus 1 over r times 1 plus r. So this is now what caters for the element of investing at the beginning of the period. So you can write that. And then we have an illustration. So back to the handout, there is an illustration. Finding value of an annuity due. We have an illustration for that. If you can check in the handout, They're saying, assuming the above example, the investment is made at the beginning of the year rather than at the end. So example, what is the value of shillings 100,000 investment annually at the beginning of each of the next 5 years at an interest rate of 12%? So let's do that. So we're saying, what is the value of shillings 100,000? So annuity, the annuity is 100,000. What is the value of shillings 100,000 investment annually at the beginning of each of the next 5 years? The period is 5 years. Interest is 12% per annum, and it's at the beginning. So future value of annuity due is equals to the annuity, and you need to be